Example 1.4.2. A particle of weight 8 newtons is at rest, so that means it's not moving, on a rough horizontal table. So horizontal and rough meaning there's friction. The coefficient of friction between the particle and the table is 0.5. Mu is the symbol we use for the coefficient of friction. A horizontal force of magnitude p newtons, note it's a horizontal force, is applied to the particle. Describe the motion of the particle when the value of p is, and then there's 3 different situations here. Each time p is getting stronger. So initially it's at rest, it's not moving, but then this force p is applied. We need to describe the motion of the particle in each of the 3 situations. So I've drawn my diagram. Particle has a weight of 8, so 8 straight down, not 8g. Nope. If the mass was 8, then the weight would be 8g, but here we've been told the weight, so the weight is just 8. P could be pushing left or right, it doesn't make any difference, so long as you draw friction pointing the other way. So whichever way you've drawn P, friction will then act the other way. So if P is strong enough, this object on my diagram would move to the right. Therefore friction is trying to stop that happening. Friction will be acting to the left. Now let's have a look vertically. There is no acceleration vertically, and there never will be. If any acceleration happens, it will be moving sideways. So R and 8 are always going to be balanced. So in this situation, R will always equal 8. Please don't jump to the conclusion that the normal reaction force always equals the weight of the object. It certainly does not. But in this situation, in this diagram, R and the weight will be equal. So therefore F max, using a formula from the previous page in your notes booklet, which is mu times R, is going to be half times 8, so 4. And newtons. So 4 newtons is the strongest that the friction can be in this situation. So part A, what if the pushing force or pulling force P was just 2 newtons? Pause the video and have a think. Would the object move? If so, how would it move? And describe that if P was 2 newtons. Alright, I hope you had a go at thinking what would the motion be like if P is 2 newtons. Well, if P is just 2 newtons, friction can match that. Friction isn't always going to be 4 newtons. On the previous page in the notes booklet, it said something like friction only acts sorry, let me start that sentence again. Friction force is only sufficient to prevent motion. So if we have a 2 Newton force pushing sideways, then friction only needs to be 2 newtons to keep the object where it is. Right, I hope you've had a go at that. In B, there will be no motion because friction can match the pushing force. So in part B, friction can match it. However, that's as strong as friction can be. So the object will be in limiting equilibrium, which means it will be on the point of moving. So if the pushing force got any stronger, it would move. So part C, P is now 7 newtons. Pause the video and have a think. What would that motion be like? Okay, so part C, if P is 7 newtons, friction cannot equal that. So there will be an imbalance, there will be a resultant force, and the particle will accelerate. Very important we use that word. Don't just say the particle will move. The particle will actually accelerate in the direction of P. In this situation, how strong will the frictional force be? Well, friction doesn't give up. It doesn't stop trying to prevent motion. So friction will be at its maximum value, still trying to prevent motion, but it's lost the battle and motion is actually taking place. Okay, that concludes this example.